On this 2.7 EcoBoost F150 P0304 means the PCM detected a misfire on cylinder 4. In plain language, that cylinder may not be getting clean combustion. The truck may run rough, shake at idle, hesitate, feel down on power, or turn the MIL on. If the MIL is flashing, take it seriously because the misfire may be severe enough to risk catalyst damage. Broadly, this can involve ignition, fuel delivery, vacuum or EVAP leaks, EGR influence, base engine condition, cam or crank signal input, or fuel quality. Before clearing anything, save the captured operating data, because clearing PCM codes erases the freeze frame information. Start by checking what codes are actually present. If other codes are there that change the direction, check what they mean first instead of chasing the cylinder for misfire by itself. For P0304 on this engine, continue into the misfire path. Pull the PCM freeze frame data, write down the available PID values, and compare those captured values to the typical reference values. If anything is out of range, pause this cylinder 4 path and move into the appropriate data-driven diagnostic path. If the captured values look normal, keep going into the mechanical screen. Next, run a relative compression test. If all cylinders pass, continue. If a cylinder does not pass, check that suspected cylinder with a leakage test, and if leakage passes, follow with a compression test so the cylinder concern is handled before ignition or fuel parts get blamed. After that, check for non-misfire continuous memory codes, COO codes, and COR codes. If one of those is present, set P0304 aside for the moment and diagnose the next code that is driving the system. If those checks are clean, run the power balance test. If all cylinders contribute correctly, move ahead to injector flow. If the power balance shows a contribution problem, branch into the ignition checks for the suspect cylinder. If a scan tool routine called for in this path is not available, follow the available diagnostic direction, instead of inventing a substitute test. On the ignition branch, do not unplug a coil-on plug unit with the engine running. That can damage the coil or the PCM. With the suspect coil disconnected and the ignition on, check VPWR at the applicable coil connector pin. On this 2.7 EcoBoost, that feed must be greater than 10.5 V. If it is low, repair the open circuit and verify the repair. If VPWR is good, continue to spark testing for the misfiring cylinder. Disable the fuel pump by removing the fuel pump fuse. Disconnect the coils from the spark plugs. Connect an adjustable ignition spark tester THX 458 or equivalent to the coil boot. Set the tester to 40 kV and crank the engine 3 times. Then set the tester to 25-28 kV and watch for spark while cranking. A good result at 25-28 kV sends you to the spark plug checks. No spark on this engine supports installing a new coil or COP, followed by verification. Inspect the spark plug for damage, where carbon tracking deposits and correct gap. If it is not okay, repair it, adjust the gap, or install a new spark plug as necessary. If the plug looks okay, measure resistance from the center wire to the terminal. The resistance should be between 2,000 ohms and 12,000 ohms at a room temperature of 25 degrees C, 77 degrees F. If it is outside that range, install a new spark plug and verify. If you were sent into this ignition testing from a symptom path instead of this P0304 misfire path, follow that symptom direction. If not, continue to the return check. When this ignition branch was reached from the power balance step, return to the main misfire path at injector flow. If that return point is not clear, pause, recheck the earlier diagnostic path, and avoid guessing before treating the concern as intermittent. Also remember that a damaged ignition system may raise catalyst temperatures, so look over nearby components for heat damage. Now run the relative injector flow test. If the injectors flow correctly, continue. If one does not, check for a loose connection and for damaged or corroded pins, repair what is found and then continue. Next, check the fuel system through the proper fuel system diagnostic path. If a fuel concern is confirmed, repair it and verify. If fuel does not explain the misfire, inspect the vacuum hoses for damage or deterioration. Some vacuum leaks can be heard. Remove any restriction found, install parts as necessary, and also inspect the EVAP lines and hoses for wrong connections or damage. If that area is clean on the 2.7 EcoBoost, move to EGR influence. Start the engine, bring it to normal operating temperature, monitor EVAP% with the engine idling, then record it again with the ignition on and the engine off. Compare those values to the typical reference values. If the values are out of range, move into the EGR diagnostic path. If they are in range, turn the ignition off, disconnect the EGR assembly connector, use the captured conditions and customer information, and try to recreate the misfire. The PCM may store EGR-related codes during this check, and recreating the original condition may require driving. If the symptom cannot be recreated, inspect the EGR for contamination, unusual wear, carbon deposits, binding, or other damage, then repair and verify as needed. If the misfire can be recreated with EGR disabled, check base engine integrity next. Work through the mechanical checks in order. Cooling fan drag or interference where it applies, accessory drive concerns, compression and cylinder leakage, valve train condition, PCV leaks, component checks, and MRC linkage or restriction if equipped. Engine temperature may affect the results, so keep that in mind when judging the test. If a base engine concern is found, repair it and verify. If no base engine concern is found for P0304, check the suspect fuel injector with the engine running by commanding that injector off with the injector disable PID. If engine RPM changes, keep going. If RPM does not change, inspect the suspect injector connector and pins for damage, corrosion, or an incorrect connection. If the connector and pins are okay, install a new fuel injector and verify. If injector disable PIDs are not available, continue as though the RPM response check passed. If cam or crank sync-related codes are part of the picture, start the engine and monitor the sync PID. A CMP sensor installed out of synchronization may set a code, so verify correct CMP sensor installation before moving on. Then check the generator for excessive electrical noise. Start the engine and listen for audible electrical noise. Shut the ignition off. Disconnect the generator or regulator B+ connector, restart the engine, and compare the noise. If the noise decreases with B+ disconnected, diagnose the charging system noise concern. If it stays constant, continue. With the ignition off, inspect the CKP wiring and harness for physical damage that could create an intermittent short. If the harness is okay, inspect the crankshaft pulse wheel for damaged teeth, wobble, or looseness. Inspect the crank pulley for wobble, and check the CKP sensor for damage. If those are not okay, repair as necessary, verify CKP sensor installation, reset KAM, and carry out the misfire monitor neutral profile correction with the scan tool. If they are okay, check for biased oxygen sensor input by monitoring EQRAT11, ECRAT21 LOMFT 1%, LOMFT 2%, SHRTFT 1%, and SHRTFT 2%. Then compare any suspicious values to reference values. If an HO2's concern is present, check the HO2's exhaust system and HO2's mounting flanges for leaks or damage, then repair and verify. Finally, check recent repair history. If rotational components such as the crankshaft, pulley, camshaft, flex plate, flywheel, pistons, connecting rods, or front-end accessory drive parts were replaced, the misfire profiles may need to be relearned. Carry out the misfire monitor neutral profile correction with the scan tool, then verify the repair under the original conditions, and confirm the cylinder misfire count is below 10 in mode 6 on board test results. If there is no such repair history, and the fault still has not been found, pause, recheck the earlier diagnostic path, and avoid guessing before moving into an intermittent diagnostic path. Keep verification separate from testing. Anytime a concern is repaired in this path, clear the PCM codes, repeat the self-test, and reproduce the captured or customer-reported conditions as closely as possible. The takeaway is simple. P0304 is not just a coil code. Work it in order and let the test results move you from data to mechanical condition, to ignition, fuel, airflow, EGR influence, base engine integrity, crank signal, oxygen sensor bias, and recent rotating component repair history. For more diagnostic training, visit stepdiagnostics.com.